Today we're going to be working with package management, which is adding and removing packages, kind of the control panel program section. There's a few options we're going through. We're using the manual pretty extensively. In the learning plan, actually I'll put my screen on your screen in a window first of all. Sure. With all these different interactions, I hope that everything's going to keep working. My VMware workstation is not responding. Does everybody see my screen?
Yeah.
Okay, so that part's working. Oh, there's VMware workstation. I'm going to just start my virtual machine, but we're not going to get to it right away. We're going to work on a couple other things. We'll be working with just the Ubuntu server. We won't be working with the desktop today. I would strongly suggest that you be taking a snapshot right now before you even get into the package management things. That way, as we make changes, it's you have something to revert back to. Even if you took one at the end of class last week, it's not a bad idea just in the practice of that. I did that already, so I actually need to revert back to that snapshot. And I'm going to take another one. Snapshot, take snapshot, and I'll call it pre-package management. And we are working on the server, the Ubuntu server. That way, if there were any minor changes between last week and this week, or if you happen to do something or didn't take the snapshot, it's a really good practice to get to. Snapshots are our friends.
It's gonna bite.
It's going to bite you, absolutely. I'm just going to power this on, and again, we're not going to be using this right now, so you can go ahead and minimize this.
Pre-package management.
You can call it anything you want. Pre-Chapter 3, pre-package management, pre-add remove programs, or whatever. And did you get a chance to read the chapter? You saw the different... Yes, it's a wonderful chapter. Okay, and again, the idea is not that you memorize everything in the chapter, it's just knowing where we're going with it. We will be going through that chapter pretty much step by step. I'm recording this as well, so in case we go kind of quick or you miss a couple steps, hopefully you'll be able to review it and see it again. I'm going to go to the learning plans, and we're going to do a couple things. Actually, let me rearrange these. So here's Learning Plan 3. And the purpose of this learning plan is to introduce you to the various Ubuntu server package management systems, and we get to play with them. Some are easier than others. It just gives you a variety of ways to install different things. The first thing I want to do is do a little bit of background on Linux. I know that you had Linux 1 and you covered all this, and I'm sure you're all perfectly clear on the difference between Linux and GNU and sort of how all that works. I was reading some other articles kind of related to what we're working on, and I saw this really good one, and so I put a link here. So reading the Linux and GNU system. It's a website, and I'll leave that out there so you can read this as well on your own. I'm going to read a couple parts on here together as a class, though. Many computer users run a modified version of the GNU system every day without realizing it. Through a peculiar turn of events, the version of GNU which is widely used today is often called Linux, and many of its users are not aware that it is basically the GNU system developed by the GNU project. There really is a Linux, and these people are using it, but it is really just a part of the system they use. Linux is the kernel, the program in the system that allocates the machine's resources to the other programs that you run. The kernel is an essential part of an operating system, but useless by itself. It can only function in the context of a complete operating system. Linux is normally used in combination with the GNU operating system. The whole system is basically GNU with Linux added, or GNU Linux. all the so-called Linux distributions are really distributions of GNU Linux. Making sense? Kind of. It's early on a Monday. Did you know this before?
Yes.
Did you remember this from before?
No.
No. Yeah. So you probably got introduced to this somewhere along the line, but I knew the same reminders just over and over. It's like it sort of all gets blurred together of what is what. So Linux is the kernel. That's the part that actually makes it all happen together and interact, and I allocate resources to one application to another. It's not a complete operating system. It's just the basic part of the operating system, the underlying part. It's everything around it that makes it a full operating system. And we're dealing specifically with GNU, and later on the article talks about another version of there. Programmers generally know that Linux is a kernel, but since they have generally heard the whole system called Linux as well, they often envisage a history that would justify naming the whole system after the kernel. For example, many believe that once Linus Torvalds finished writing Linux, the kernel, its users looked around for other free software to go with it and found that, for no particular reason, most everything necessary to make a Unix-like system was already available. What they found was no accident. It was the not quite complete GNU system. The available free software added up to a complete system because the GNU project had been working since 1984 to make one. In the GNU manifesto, we set forth the goal of developing a free Unix-like system called GNU. The initial announcement of GNU project also outlined some of the original plans of the GNU system. By the time Linux was started, GNU was almost finished. And then it sort of goes into a little bit more detail. Way down the bottom, it talks. Some people sometimes ask whether BSD2 is a version of GNU, like GNU Linux. BSD developers were inspired to make their code free software by the example of the GNU project, and explicit appeals from GNU activists helped persuade them, but the code had little overlap with GNU. BSD systems today use some GNU programs, just as the GNU system and its variants use some BSD programs. However, taken as a whole, they are two different systems that evolved separately. And actually, the paragraph above that says BSD was developed at UC Berkeley. Originally, it was non-free, but became free in the 90s. And so there are two different sort of channels or chains of that. It's a good idea to understand Linux and the background of it. We kind of just glossed over it and just work with it at the application layer, which is fine if you're a user. When you're working at a little bit deeper level, as you are in IT, as an IT professional, you should understand some of the backgrounds and the reasonings why we name things, where they get this name from. Well, this is where it's coming from. Just like we work with Windows, yeah, the millions and billions of people around the world can use Windows, and they do it on a daily basis. That does not make them an IT professional because they use Windows every day. We, as professionals, just need to understand Windows a little bit deeper, even at the kernel level, the operating system, basic levels as well. I'll leave this article out there, so please take advantage of it and read the rest of it. There's always disagreement of even how to call GNU. It is GNU. You can look it up. That's what it is. What does GNU stand for?
GNU's not Unix.
GNU's not Unix. What do we call that when we? It's a recursive. Yeah, it's a recursive acronym. So we actually take the acronym as part of the acronym, and there's lots and lots and lots of those. Like wine. Wine is not an emulator. Is another good one. That's a recursive acronym. Okay. Here's another, by the same person who is part of the GNU project. It sort of talks about how GNU was named. Actually, we're going to take a few minutes to just listen to this. I think this should work. It is a .ogg file or an .ogg file. I had to install VLC player in order to play it. And I actually have it downloaded already. Oh, hang on a second. I must have the wrong sound system here. Oh, that's not either.
Program. And there was a hacker prediction.
Okay, start again. Sorry.
We hackers always look for funny, clever, naughty names for programs. Because thinking of the user being amused by the name is half the fun of writing a program. And there was a hacker tradition that when you're writing a program that's similar to some existing program, you can give the new program a name which is a recursive acronym that says that this program is not the other one. So, for instance, in the 60s and 70s, there were many Pico text editors, and most of them were called this Pico or that Pico or whatchamacallit Pico. But one clever hacker called his version Tint, for Tint is not Pico, the first recursive acronym. In 1975, I developed the first Emacs extensible text editor, and after that, there were many imitations of Emacs. And many of them were called this Emacs or that Emacs or who's what this Emacs. But one was called Fine, or Fine is not Emacs. And then there was Sign, or Sign is not Emacs. And Mince, or Mince is not complete Emacs. And Ina, or Ina is not Emacs. And then Ina was almost completely rewritten, and the new version was called Spy, or Spy was Ina initially. So you can have lots of fun with recursive acronyms. I decided to look for a recursive acronym for something is not Unix. But it took only a minute or so for me to discover that all 26 of those possibilities are not words, so none of them was especially funny. So I tried another way of doing it. I made a contraction, and I discovered that the word GNU, which is one of the most humor-laden words in the English language, could work. It could stand for GNU's not Unix. Well, with such a funny word to use, my search was obviously ended. I should point out, of course, that the reason why this word is used for so many jokes is that the dictionary says it's pronounced new. And so the practice of asking what's GNU didn't start with the GNU project. There's even a funny song inspired by and about the word GNU. And I should also point out that this word is a loan word from an African language, and the correct pronunciation has a click sound in it. When the European colonists got there, they didn't bother learning to pronounce this click sound. Instead, they left it out. And they wrote a G in the word simply to mean there's a sound here that we are not trying to pronounce. And then somebody else who was writing the dictionary said, well, the Europeans pronounce it this way and spell it this way, so these are correct and everything else is wrong. I've been invited to visit South Africa next June, so I hope I will finally have a chance to learn to pronounce the word correctly. That is when it's the name of an animal. But when it's the name of our system, the correct pronunciation is GNU. So please pronounce a hard G. If you talk about the new operating system, you're going to get people very confused. You see, we've been working on it for 17 years now. So it's not new anymore. But it still is and always will be GNU, no matter how many people call it Linux by mistake.
Okay, what do you think? Well, this is one of the guys, Richard Stallman, is one of the hackers, one of the people who originally come up with these programs. Just curious, do you have like a seeing him, hearing him, listening to what he's saying and how he's saying it, any observations or just curious? Just what's your first gut reaction listening and seeing him?
Holy beard.
Hippie? Holy beard?
Hippie biker.
Okay, what else? They're obviously passionate about their work. They're very prideful of their work, and they definitely want the word to be brought out. This is what I did. This is what I can accomplish. You know, that whole world is very self-confident, and they need to be. I mean, to be really reassured of themselves. And this is what we did. This is how we did it, and just trying to get that message out there. How many of you have heard of him before? Okay. Through the article you read. Okay. Prior to that?
Yeah.
Okay.
This article that you have linked to learning from.
Right.
But,
I mean, prior to reading that article, did you?
oh yeah.
Oh, you okay? Good. Linux 1. It's one of those names again that you hear and you kind of forget about. There's a lot of industry people that we just kind of tend to hear. It's like, who founded that again? What's that person? So, well, good. And again, those links will be out there. I also put out some command guides that I found. It might be a good time just to practice some of these. I heard a lot of people just asking, you know, how to do certain basic things. These aren't the best guides in the world. I didn't create them. You know, of course, if I did, it'd be so much better, obviously, right? But I didn't create them, so, you know, we're going to choose something that's actually out there already. A Unix Linux command reference. These are just basic commands that you can work with. It's just a one-page sheet. It's 8.5 by 11 if you want to print it out. It wouldn't be a bad thing to keep in a folder somewhere. You have file commands. ls. ls is very, very common, and so is just moving around the directory structure, the change directories. If you're not comfortable with these, because we don't use them very often, just practice. You know, make directories, start navigating up them, view the directory contents, copy files, and just sort of practice some of these routines. We don't do a lot of these in class because we're working with a lot of packages and administer those packages, but we still have to understand we're working with an operating system that we should feel comfortable with the file system, because there are times that you're going to have to copy a file in a command line or to make a directory or something. Process management, we deal with this a little bit. Maybe kill might be something we'd be working with. Is sort of in the Windows world of closing or forcing close an application. We can kill a process. We could kill all the processes named a certain procedure, but usually do individuals with their process ID. File permissions. This is very confusing, at least if you don't use it a lot. Even to me, I have to look them up, and it's just like, okay, making sure I get all the correct syntax on there. Okay, what do I really want them to have, and making sure to do that. The 777, sort of like the global, give everything to everybody. If we don't know what to do, this is what we do. Not a good practice. It makes it to work, but you know that's not the right way, unless you really need to do that. It's sort of like in the Windows world when there's some kind of firewall issue going on. So instead of figuring out which ports to open, what do? Turn off the firewall. Oh, everything's working great now. We can move on. Okay, it's sort of the same concept. It's an overkill, but makes you unsecure. SSH. We're actually getting into some SSH stuff later on using OpenSSH. In a couple weeks from now, we do remote management. So, did you use SSH in Linux 1? No. Okay. Searching. Great ability to do searches for patterns in files or directories themselves. System information. Sometimes it's just nice to know some of these things. The man command. Very, very useful. Typically, the Linux world has really good documentation in their manuals for a command. Examples, details, lots of options a lot of times in there. So again, just kind of remember those. Compression, it's good to know there's different types of compression. I'm not going to work with anything like that right now. Networking, actually next week we're talking about networking in class. So these are some of your networking commands. Very similar to the Windows world. Sometimes commands match up between the Windows world and the Linux world, and sometimes they don't. Ping does, so that's good. Installation. These are the generic Linux reference commands for making packages and installing them that way. We are actually going to be using different package management things in class, and that's where you're going to see the differences there, so that won't be the same. Shortcuts, oh, you can't have an operating system without shortcuts. Control C, Control Z, Control D, and W. Sometimes it's nice to have that. It's hard to remember. That's why cheat sheets are nice. So again, you certainly can print that out and keep it just as a reference sheet next to you, unless you just want to have the PDF files available. We have the same thing available for the Ubuntu Server Guide, a little bit more specific for Ubuntu Server. They're both by the same place, by the way. Whoever this is, Fosswire. That's what it is. Thank you. I knew that and I forgot. I need a cheat sheet for the cheat sheet. The Ubuntu reference, remember everything in Ubuntu is sudo. It runs the command as root. Not everything. Anything goes root. Most of the things that we're doing as a server, though, adding packages and changing IP configuration or remote management, all that stuff does require root. Again, I'm trying to equate to Windows as the equivalent it's the Windows equivalent of clicking on the little yellow box that says, are you sure you want to run this? There is no changing user or switching users to root. There is no root account. Well, there is, it's disabled. So that's the biggest thing with Ubuntu for people from other versions of Linux transferring over, that you're using a sudo command. Sometimes you'll end up typing commands and say it won't run unless you're root. It's like, oh yeah, sudo the command. So that's probably the biggest thing here. Display settings. I'm not going to get many to these because we'll cover some of these throughout the semester. The services, package management. This is what we're working on today. The different apt gets, plus others. We actually work with aptitude and networking, like I said, will be next week. There were the Linux generic ones, and some of these will work in Linux generic as well, but these are specific ones that we'll be looking at. Special packages, we can install different desktops, and we're actually going to play with that today. Firewalls, we have a security chapter. We're talking about the firewalls area, and then application names. This is good to remember. In the different environments, the file managers, the web browsers, text editors, of knowing what those applications are to do those basic functions. File management, text editing, and web browsing are really your three essential applications that you need with any operating system to work through that. System, I don't even think we're going to get into these at all, but they're down there. So again, you can feel free to print those out, or at least keep them saved somewhere. Yes?
I have a question about our server and our client.
Yes.
Not supposed to install VMware tools?
Do not install VMware tools, because we're going to be doing that today, part of our package management, and not even normally how do you install VMware tools? What's that? Not to update them either. Do not update your server or your desktop, and don't install VMware tools. How do you typically install your VMware tools? You go to the VM host, and you tell it to install it on the guest. And then if you took the Novell class, there's an extra step you have to do on the server. You have to type in a command. In Linux, in fact, you have to type a command as well. It mounts a virtual image of a drive. And we'll actually talk specifically about that today, though, about installing VMware tools. Did you get it installed?
No.
You did? Good.
I just thought I remember you saying some open source.
He said something about that.
It's
I
probably-
did.
You probably said it when I wasn't supposed to be following them on.
Yeah. No, but that's a great question.
Mhm.
Okay, let's go through the chapter. I'm just going to go through the chapter. We'll be using just their examples today. I'm not going to get real fancy and have you do all kinds of extra installation or removal of applications. We're going to make it very, very simple. Today is a day to introduce you into the package management stuff. So in later chapters, when we decide to work with FTP, that you'll feel comfortable with installing FTP. How do I install that on my server? How do I configure that then and use that then? So there isn't even any extra homework to practice with. It's just a matter of going through the chapter and feeling comfortable with the different means of installing different applications and services and packages. Actually, I should concentrate on packages. So, okay. Ubuntu features a comprehensive package management system for installing, upgrading, configuring, and removing software. In addition to providing access to an organized base of over 35,000 software packages, the package management facilities also features dependency resolution capabilities and software update checking. What does that mean? What does it do? Okay, first of all, it has access to an organized base of over 35,000 software packages. There's a lot of stuff out there. What do we mean by packages?
Programs?
Possibly.
EXEs,
Kind of like the EXEs. It's the EXEs and all the dependencies. In the Windows world, would be equivalent to like DLLs, all your system files, all the other things about it. Applications don't just run on themselves. They require lots of stuff around there. In the Windows, we typically keep them sort of together. If I run Microsoft Word, I'll have Word executable and all the support files that go around there, the DLLs, the dynamic link libraries, and so on. We start the same concept in the Linux world, except even broader. Not only do I have those dynamic link libraries or those shared files just within my suite, just within the Microsoft suite, but they're across the whole platform. So when, if I want to print, I don't have my own printing module. I use the printing module that's there. Now that's kind of an overly large example, but because we're all sharing code in the Linux world, so the open source environment, we're relying on other applications that have been written, other system files, all that kind of stuff. If I require something to be installed at a certain level, and you're running at another level of that DLL, it's not the application that's out of date or not the right version, it's the dependency that does that. And so I'm checking all those dependencies on there, and it's much more interdependent in the Linux world than Windows. Again, the Windows, we still have some of that, but it's not nearly to the extent as Linux. So it's looking for that dependency and then the resolution of that. Do I upgrade? Is it this other version compatible with the update? If not, where do I put this and how do I manage those separately? So it's a very, very complex system. Because it is so broad and so a shared environment, I have to manage that. And it does it extremely, extremely well. It also does the update checking as well. It's sort of like, anybody have any tablets, like Android tablets or smartphones or iOS operating systems? We have an App Store or what else we have in the App Store? Google Play. So the place that we purchase or we download our applications is the same place that manages the updates for them. So if I go to one place, it tells me, oh, these are the things that I have installed, these are the things that I could install, and these are the things that you have installed that could use updating. Is that familiar with that? Windows doesn't have that. we have the control panel, and we can see which programs are installed, but there aren't little icons next to my various applications that says, oh yeah, this one can be updated, or this one, and there isn't an update all button on the bottom like on your iPad does. You know, update all those different things. Now, I'm not saying Windows is bad, they just do it differently. Each application is really looking for its own updates. That's why you log in the morning and then Java wants to check for an update, and you know, my different applications are checking, and they're all going out there looking for their own thing. That's because they're all going out to their own places. I'm going out to Cisco site, or I'm going to Microsoft site, or I'm going to Oracle site, or whatever, to find that kind of stuff. The Linux world tries to deal with that a little bit better, or a little bit differently, by doing what? And what are those places called? Repositories. And there's not just one, there's several, but you know, we think of a central place of putting that kind of stuff. Imagine that in the Windows world, that we have one agreed place to put all your stuff. Well, we kind of have that. What do we do that with? Not with applications, but with what? In Windows? Drivers. When I go up and I say, hey, there's a new video driver, did that actually come from my video manufacturer? Well, it was written by my video manufacturer, but where did it get put? Onto the Windows Update site. And so now it knows my modem's been updated, my NIC's been updated, my video driver's been updated, and sort of goes through that channel. But do you see the benefit of getting driver updates? I don't have to do all those individual. It's sort of just expanding that from drivers out to full packages. And we don't try to think of this more as a package than as an application, because sometimes packages will involve all kinds of stuff, all kinds of services. They're just put together nice and neat. There's several tools available for interacting with the packages, from simple command line utilities. I like the way that is, simple command line utilities, which may be easily automated by system administrators, to a simple graphical interface, which in the examples that they give, the graphical interface or the text-based one that we're going to go through, to me, is actually much more difficult than the actual command line. I actually think the command line one is pretty simple once you get used to typing a lot, sudo, apt-get, whatever. But, you know, so you're getting used to that. So we're going to go through that. We are going to go through the chapter in here, and then there's a couple other examples, actually from a textbook which we'll be going through, and then I'll show us some of our other applications. So, Ubuntu's package management system is derived from the same system used by the Debian GNU Linux distribution. The package files contains all the necessary files, the metadata, and instructions to implement a particular functionality or software application onto your Ubuntu computer. So don't just think of it as a specific piece of software or a specific application. Sometimes it's adding full function or different functionality to it. The Debian package files typically have extensions of dev and usually exist in repositories and so on. Moving down, many complex packages use the concept of dependencies. They're additional packages required by the principal package in order to have functionality. And they use the example of a speech synthesis package as an example. Okay, the DPKG, the Debian package-based system. It can install, remove, and build packages, but unlike other package management systems, it cannot automatically download and install packages or their dependencies. That's why we don't typically use it. It's not recommended in the books that we're working with, and even we talk later on about VMware. It's the VMware host that uses the DBKG installer, the Debian Package Manager, and again, it's just not recommended. We're just going to take a look at these real quick. Well, here. Does everybody have your user guide up on another screen somewhere, so I don't have to have it up on the screen? Okay. Okay, so we're going to start with some of these. First of all, Ubuntu login. Ubuntu Paul B is the server name. We named it Ubuntu with your name on there. And so, let's see, my login should be Paul B, and we should be using password as our password. As we log in, you can tell that some of the stuff is working in the background already. It tells me that I do have 80 packages that can be updated. And we'll be taking a look at that later of actually updating that. Now that's based on the current list of repositories, and all that's going to make sense later on. Okay, and again, just to use those examples in the book, to install all the package, to list all packages installed in the system, we can just type the dpkg-l for listing them. If you're looking at a lot of things, you can sort by or search by, what are the ones that are related to Apache or Apache 2. Remember the pipe command, or the key, that's the one above the enter key. You need to do the shift to get there. And we're using grep as our search function, which you should be at least aware of at some point. And I don't have anything Apache 2 installed. I just typed in text, and these are the ones that have different text in it. So it's doing a search for all the installed packages that have text in it. If you want another one, I don't know. Anything PDF, nothing PDF. The server is installed with really, really limited things. What IP? Oh, that's everything under IP. Equipment, manipulating file system, whiptail, scripts. Shell will be a good one. Lots of shell. The bash shell, shell multiplexer, and so on. To list the files installed by a package, in this case the UFW package, it gives you the next command. We're using a capital L this time. And the UFW package. Now we can see all the files that are installed by that package. If we were, and again, it's almost like in the Windows world, when you install an application, it's not just Word.exe. You can watch it install. It just does on and on and on, list of files. This actually shows you which files are installed with that application. If you're not sure which package installed a certain files, you're looking at a file, it's just like, where did this come from? What application is this associated with? Again, in the Windows world, we don't really have that functionality or that feature. It's like, here's a DLL in your Windows system directory. Where'd they come from? There isn't a reference to saying, this is what installed that. You can look on the internet and says, oh yeah, that's related to this program or this program, but there isn't really that link. This does. And so we're going to use a host.config file, and we're going to find out which package installed that. So let's see, we have a -s etc host.config. And that was installed by base files. So base files was the package that was installed by that. And again, they don't give many examples in here, but one thing you could do is just go through. I'm sorry?
What's dash?
The dash S tells you what package installed this? So in this case, the base files, which is the installation of the operating system, that's what installed that host.config file. I'm not going to see anything from there. Okay, let's see here. To output, the output shows that the file etc host belongs to the base files package. Many files are automatically generated during the package install process, and even though they are on the system, it may not show which package they belong to, so it doesn't always do that. You can install a local .deb file by entering the sudo and then the dpkg, the Debian package command, with the command that you need, and you use the -i and then what file you want to do. You actually change that zip_3 whatever to the actual Debian file, and that's going to install it for you, and that goes through the install process. It does not download the stuff, so that's the one biggest difference. Is you have to grab that .deb file, get it onto your system, remember where you put it, that's all the tricky part, and then running that command, sudo Debian package, and then pointing -i to install, and then the package file name. Let's see, uninstalling a package, we're going to use a -r instead of -i, and then we list the what package we want to uninstall. So when we install, we actually need the file name. When we uninstall, we use the actual package name. So text editor, say it's just text is the package. We install text.deb, and then we remove text is the actual name. There's a big note under there. Uninstalling packages using the dpkg command in most cases is not recommended. It's better to use a package manager that handles dependencies to ensure the system stays in a consistent state. For example, removing that zip package will remove the zip package, but any packages that depend on it will still be installed, but may no longer function correctly because that dependency is not there. So this is pretty much down and dirty, straight to the point. I'm installing this, I'm removing this, and it's going to be very, very clear cut. So this really isn't a true package management, especially because it doesn't deal with the dependencies. So you need to be aware of it though, because it's referenced. In fact, it's on the Linux reference guide, and there are occasions that you might need to install that way. So at least be aware of it. And as always, for more information, there's the man command. This is really good to remember. I'm glad this came back up. The manual page, line 1, press H for help or Q to quit. If we hit H, it brings us all the different commands for navigating these manuals. Anybody remember these? Yeah? You tried to put these out of your mind, and now they're being brought back. This won't be so bad. The biggest things I should probably recommend to you is the Z and the W. Forward one window and back a window. Line by line is great. Z and W, they're even like on the keyboard that way. I want to go a page up, it's a W. Z is a page down. It's almost directly across from your page up and down on your keyboard, so I can hit up and down to navigate through page by page. So as you can see, there are hundreds and hundreds of keyboard commands just to view this file. If you can remember 2, you'll be great, and that's going to be the Z and W for paging up and paging down. When you're done, you hit Q, and that's always on the screen, so at least you're not stuck in there. I hate getting in situations where it's like, what do I do? Where do I even go from here? What's that command again? Is it shift, this, whatever? So it is Q. Okay, that's a sort of a review of the Linux GNU stuff. It got us into the server. It's doing somewhat of the package management background, and then we did talk about the one command. I am going to take a break now, though. because we're getting back, we're getting into the apt get command, and that's going to be where we'll be really focusing a lot of different things. So we'll take a break and be refreshed and start with a new topic. Questions or comments? Good.